Hi everyone, thank you so much for joining us on this introductory series on building web APIs with ASP.NET Core. My name is Philip, and over the course of the next few videos, our goal is to be able to give you the information that you need to be successful when you want to build web APIs using .NET. Now, if you're unfamiliar with .NET, and maybe this is the first time that you're really starting to build stuff with it, I recommend that you first head over to the .NET website. Here on the site, you can get access to a lot of great introductory level video content that covers topics such as C#, ASP.NET Core, and even .NET Core. I think these three videos in particular will give you the prerequisites that you need to be successful in this series. Before we really dive into the conversation about building web APIs, I think it's important that we understand what are they. What are web APIs? And to do that, let's separate that term into two parts. We'll have the web part, and we'll also have the API part. Now, when we think about web, we usually talk about ways that we can exchange information with each other over things like HTTP or even a web browser. When we think about APIs now, well, API stands for Application Programming Interface. And essentially, those are collections of operations that you can invoke on a machine either locally or remotely. Now, putting those two terms back together and we get web APIs. Web APIs are operations that I can invoke over HTTP to be able to leverage the functionality that those operations provide. And I can use that inside of my application to really enhance the experience that I'm trying to create. Now, it turns out, regardless of the app that you're building, you can make use of a web API also. So whether you're building a mobile app or a desktop app or a game, you can do things like leaderboard tracking or managing contacts, looking up business information or recipe information. It also turns out that web apps can use web APIs, and web APIs can use web APIs too, which I think has a really cool dynamic to how we could put these applications together. Now that we've seen some examples of apps that could use web APIs, why don't we talk about examples of web APIs themselves? And within the Microsoft ecosystem, I think there's a few interesting operations we could look at. Microsoft Graph, for instance, is a collection of APIs that gives us information back about our M365 account. If you use Azure DevOps for your CI/CD, you can get information about your DevOps pipeline using the Azure DevOps API. Also, if you're interested in doing machine learning and adding that functionality to your app, you can use something like the cognitive services. And if you're building games, again, PlayFab is an interesting set of APIs that could do things like leaderboard tracking, scoring, and player management. Now, if some of this stuff sounds really interesting to you, and hopefully it does, stay tuned for the rest of the course where we'll really dive into the business of building web APIs using ASP.NET Core. In the next video, we're going to talk about HTTP, which I think really forms the cornerstone of how we can build our web APIs. Hi everyone, thank you again for joining us for our introductory series to building web APIs with ASP.NET Core. In this video, we're going to take a look at HTTP and explore some of its fundamental concepts that allow us to share information between different places. Now, HTTP actually stands for Hypertext Transfer Protocol, and it was designed as an application-level protocol for distributed and collaborative systems. Now, what that essentially means is that it allows two systems to communicate with each other even though they may not be in the same place. One of the more common use cases for HTTP is actually powering the internet, which I'm sure a lot of us use on a very regular basis day to day. Also, HTTP is an open standard, and it was defined in a document called RFC 2616. So if you're interested in learning about some of the more intricate details about how the protocol works, I definitely recommend that you look up that document in your search engine of choice. Now, let's take a moment to understand how information flows back and forth when it comes to HTTP. The protocol relies on the concept of there being both a client and a server. The client being the application or entity that's responsible for generating requests for the resource that they want to work with. So as an example, imagine a user walks up to their laptop, opens their web browser, and now they want to find information about what are some of the most recent on.NET or Xamarin Show episodes that are available on Channel 9. So the job of the web browser is to generate those requests and send it over to the server using the address of the website. Now on the other side, we'll have the server, whose job is to receive that request, process it accordingly, And now it's going to generate an HTTP response that is going to send back over to the requesting client. The client then receives that response, processes it, and then now it's going to show those results to the user. Let's take a look and see how exactly you can compose an HTTP request. And the three main parts that we're going to look at are the request line, headers, and the body. Now the request line contains information such as the HTTP verb it's using and the path, and also the version of HTTP that's being used for this request. Next, we have the HTTP headers, and the headers are essentially key value pairs. They contain metadata that's associated with this respective request. And next, we have an optional body section. In the body section, we have information that we can optionally send along with that request that might be useful for processing it. Now let's take a look at an HTTP response. And the response structure is very similar to that of an HTTP request. But you'll see instead of having a request line, we'll have a status line. And the status line is there to let us know, well, what was the status? What was the results of actually sending that request over? So was it successful or was it not successful? Did it fail or did it succeed? Also, you'll notice that an HTTP response also contains headers. And just like with the requests, these are key value pairs that are associated with this particular response that's being returned to the client. Next, we have that optional body section. And in that body section, we'll have any information that was either requested from the client or anything that's necessarily needs to be associated with this request that's heading back over. Now, we've gotten a good look at how HTTP allows us to send information between two places and how to compose requests and responses. In the next video, we're going to learn how to create our first web API using ASP.NET Core. Hi everyone. Thank you again for joining us for our introductory series to building web APIs with ASP.NET Core. Thus far, we've covered various topics such as what are APIs, what are they used for, and even seen some examples of different APIs that we can make use of today. In the last video, we took a look at HTTP and got an understanding of how it allows us to send information between two different places. Well, in this video, I think it's about time we take a step forward and see what it actually feels like to build a web API using Visual Studio. I've gone ahead and opened up Visual Studio 2019. The first thing that we'll do is select Create a New Project. That should open up the New Project dialog box. And we want to make sure that we find the ASP.NET Core Web Application template. Now, if you don't see this item, you can search for it in that template search box that's at the top. And if you still don't see it, go and check and make sure that you have the ASP.NET and Web Development Workload installed in Visual Studio. Now we'll hit the Next button. And what we'll do here is give our application a name. So in this case, I'm going to call it Contoso Recipes because I want to create a recipes API. Now we'll hit Create again. And on the next screen, we'll be presented with some options with the types of ASP.NET Core applications that we can create. For us, we want to make sure that we have the Web API one selected. Also, on the right side, we're going to leave all of the default options as they are. So that means that configure HTTPS and also enable OpenAPI support should be checked by default. We'll go ahead and hit Create one more time. Now in the background, Visual Studio is going to take all of that information that we just entered and it will scaffold out a new ASP.NET Core Web API project that we could use. Once that's complete, we should see our project available for us inside of the Solution Explorer. Now, if you've ever done our ASP.NET Core 101 videos, this folder structure should look fairly familiar for you. So first off, you can see that we have our startup and program.cs files. Also, you'll see that there's a controllers folder, and inside of there should be a single controller called the Weather Forecast Controller. If we open that up, we'll notice that there's a single method in here called get. And the job of this method is to receive requests for weather data and then return some response. Lastly, you'll see that we also have a weather forecast class. Now, the purpose of this class is to form the shape or the structure of the type of information that we want to return from our API. Now, let's go ahead and see if we could run this. Now, for us to run this in Visual Studio, we can hit this green button that's at the top in the toolbar. Or, if we want, we can select the option of running it in Kestrel. And we'll do that by selecting the application name that's inside of this drop-down box. Now, that's the one I'm going to go with. And now I'll go ahead and hit that green button. After Visual Studio has loaded up our application and launched the web server, we should see a page pop up that looks something like this. I want us to pay attention to this blue box that's here that says get. And this is representing that get operation inside of our controller. If I hit this tryout button and execute, we should be able to see some responses that come back. So notice I get a 200 level response, and here's the information from the body of that response. And that concludes this video on how you can create new web API projects inside of Visual Studio. Now stay tuned, because next we're going to learn how we can process requests inside of controllers and action methods. So far in our series, we've learned how to create new ASP.NET Core Web API projects inside of Visual Studio. In this video, we'll take it a step further and learn how to process those requests that get sent over to our API. Because, well, what good is an API if we can't process the requests, right? And the two concepts that we'll learn about that will allow us to do this are called controllers and action methods. Now, within the context of ASP.NET Core, the job of the controller is to be able to receive requests that get sent over that match a particular path. And now within that controller, we'll have various operations defined that are able to inspect the requests, carry out any necessary business logic, and then also return a response back to our client. And these operations are usually called action methods. Now let's head over to Visual Studio and see how they work. We're going to continue working on that project that we created before. Two things that you'll notice is that we've removed that weather forecast class, and also I've deleted anything that was inside of that controllers folder. Now we'll create a new controller by right-clicking on that folder. I'm going to select Add and then Controller. In the dialog box that pops up, I'll select API, and then at the top, I'll select API Controller Empty. The next thing that we need to do is to give our controller a name. I'm going to call this Recipes Controller. Notice how I have the word controller appended to the name. I'm doing that because that's one of the conventions that ASP.NET Core uses to find controllers. Now I clicked Add, and I have my empty controller here. The next thing we need to do is to add an action method. So I'm going to paste in an action method that I created before. This action method simply returns a list of dishes, and I've added some of my favorite ones such as oxtail and dumplings. Let's hit the run button and see if it works. Now that the browser is loaded up, I'm going to select that get operation. I'll hit tryout, and then I'll run execute. And now inside of the results, I'm expecting to see that data that I specified in my action method. So there I could see oxtail, curry chicken, and dumplings. So I guess that means that our action method is working as we expect it to be. Let's close this and head back to Visual Studio. Notice on line 14 that our action method is attributed with HTTP GET. That means that it's going to respond to HTTP GET requests. Also on line 15, see how our method is actually a fairly bare bones C# function. So that means that we didn't need to do anything special to be able to process that request. Finally, I want you to take a look at line 10 and notice that route attribute. It's specifying that our controller is responsible for requests that land on the path API/ and the name of the controller. So in this case, it'll be API/recipes. Now you've seen how to create new controllers and action methods inside of ASP.NET Core. In a future video, we'll dive a little bit deeper into routing and see some other ways that you can customize action methods when you're building your APIs. In a previous video, we learned about some of the components that make up HTTP requests and responses. That include things like the status codes or the HTTP headers, or even the body that gets sent over in the message. Now, when it comes to building web APIs, there's usually a common set of conventions that our industry uses to map those components to the types of work we want our API to do. In this video, we're going to take a look at some of those conventions and learn how to implement them inside of ASP.NET Core. Now, when we talk about APIs, we usually look at them as a common set of operations that we want to execute against a given collection of resources. So for instance, those resources might be, products in our inventory or contacts in our address book, recipes inside of your recipe book. And once you have those resources, there's usually a common set of operations that you want to execute. For instance, I might want to create a new one or delete one. I might want to update an existing one or issue a query to retrieve some of the ones that we already have. And it turns out HTTP has already defined ways that we could execute these types of requests from our client. If you take a look at the table, on the left side, you can see I've defined some common actions. So create, read, update, and delete. And in the next column, I've also listed some HTTP methods that match those given actions. So for instance, if I wanted to create something, I can issue a post request. If I wanted to read something, I could issue a get request. In the last two columns, these have to do with the responses that get returned from the server. So now we need to know what is the status of that particular request. Was it successful or not? Were things created or were they not? Were they found or were they not found? Was everything okay? And we use HTTP status codes to issue those things, and that's what you're seeing here right now. Now, these aren't all the HTTP methods and all the HTTP status codes that you could use when you're building your API, but I think it's a really good start. So why don't we head over to Visual Studio and see how we can implement some of these conventions. The first thing that we'll do is open that recipes controller we created in the previous video. You'll notice that I've added some additional action methods to our controller. So we have get recipes, create new recipes, and also delete recipes. Notice all these actions have their associated HTTP method with them. So when I want to get things, I'm using HTTP get. When I want to create things, I'm using HTTP post. And also when I want to delete things, I'm using HTTP delete. And these should match some of those conventions that we saw in that previous diagram. If I decide to open up the get recipes, again, you'll notice that I'm still following some of those common conventions. So when I want to return information, and let's say this operation was successful, I could use OK. And that'll return that OK status code, and I could just give it the payload that I wanted to return. And you can see that on line 21. If for whatever reason I was unable to find my recipes, well, I can just return a not found status code. And I can use that with the not found method that you see me using on line 20. Now, let's take a look at the HTTP delete operation. And this shouldn't be too much different. Now, if everything was successful and I was able to delete this resource, then I'll just return no content. And that just means that, well, it was successful and there wasn't anything that I needed to return. Also, if something bad happened and maybe I was unable to delete it for whatever reason, then I'll return like a bad request. And you can see I'm doing that there on line 42. Now, you might notice that, I don't have all the necessary operations implemented. So as an exercise for you, why don't you try creating an update operation to update the particular recipe resource? Now, remember you have to use the right HTTP method and status codes. So try it out and let us know how it works out. In the next video, we're going to take a look at routing and learn how we can customize that inside of ASP.NET Core. If we're going to issue a request to our API, it's important that we know where it lives and how to access the particular resources that we want to work with. This is where URLs come into play, and URLs are essentially the address of our API. Now, using a combination of URLs, HTTP methods, and some other information inside the request, ASP.NET Core is able to invoke the right action method inside of the right controller to process our requests. And this is known as routing. And that's what we're going to talk about in this particular video. So why don't we take a look at an example of a URL? This one is coming from Microsoft Graph. And this is an API that allows us to get information from our M365 account. Now, if we break up this URL, we can see that it's made up of a scheme, which lets us know, for instance, what protocol that we're using. There's also a host name that lets us know, well, what domain does this API live under? And lastly, we have the path. The path tells us, how do I get to that resource that I want to work with? So if we read it out, I'm saying I want to issue an HTTP request to Microsoft Graph to get information about my account. Now, using all this information that we've learned so far, let's see how we could apply routing to ASP.NET Core. Let's open up our Web API controller. Now, the recommended way to apply routing to our Web APIs is by using routing attributes. And you might have noticed on line 10, we've had this attribute added for us ever since we created this controller. Now, using routing attributes, we're able to specify the path that we want to associate with our code. So again, on line 10, this particular route attribute is letting us know that our controller is going to be listening to anything that comes on the path /API/ and the name of the controller. In this case, the name of our controller is recipes. If I decided to change the name of my controller and call it something like contacts or products, the name of the path that it would listen to would also change as well. Another option we have is instead of using this controller syntax that's here, I could remove this and I could just hard code recipes. Now that I've changed this and I have a fixed name, as I change the name of my controller, the name of the path that it's associated with won't change. So you can do that depending on if you want to have that level of consistency. Now, this routing attribute on line 10 applies to the controller, and so therefore it applies to all the action methods inside of the controller as well. But if we wanted to, we can go a little bit more granular and control routing on the action method level. Let's check out this delete method here. Notice I have this HTTP delete attribute. If I wanted to be a little bit more specific, and maybe I wanted to delete everything, I could specify all here in this attribute. And now what will happen is that this will listen to a path of /API /recipes/all. So that whenever I issue my delete request, that's the path that I'll have to use. Another thing that we could do is specify tokens that we want to use as variables. So for instance, let's say I wanted to delete a resource with a particular ID. I could use these curly brackets and give it the name of the parameter or token that I want to use. And now here inside of my action method, I can accept a variable with the same name. And ASP.NET Core will do the job of matching those names together to make sure that the data gets passed into my action method. So now what will happen is that instead of listening to all, now this would respond to requests for delete API recipes /1, API recipes /12, slash whatever you feel like you want to put inside of there. Why don't we go ahead and debug this and see if it works? So I'm going to hit the run button and I'm going to wait for Visual Studio to build my application and spin up that web browser for me. Now that my browser's up, I can see all of the various operations for my API. I'll select the delete one since that's the one we want to work with. And notice now here I also have the ability to add this parameter whenever I try it out. So when I hit try out, and I'm going to put 12 in here for instance, when I execute that, now it should make a request to /API /recipes /12. Notice it hit my breakpoint, and then when I inspect the value of that particular parameter, it says 12. So ASP.NET Core was able to get that information from the route, and now I could use it to process the request inside of my action method. Now, there's a lot more to learn about routing inside of ASP.NET Core, but I think this is a pretty good foundation for us building web APIs. In the next video, we're going to spend a little bit more time in that Swagger UI and learn how we could really use it to debug our web API projects. Throughout this series, you've seen me use this website to debug our web API as we work on it. And you're probably wondering, well, what is this site? Where did it come from? And how does it know so much information about our web API? Well, that's what we're going to talk about in this video. We're going to learn how we're able to debug our web API using something called the Swagger UI. Now, Swagger is a collection of open source tools that make it easier for developers to build and consume web APIs. Some of those tools include things like client generation, API documentation, and even the ability for us to debug our APIs live using this UI. Underneath all of those tools, Swagger relies on something known as the OpenAPI specification. And that spec allows us to define some of the detailed things that our APIs are able to do. Now, we're going to dive deeper into the OpenAPI specification a little bit later in the series, but for now, let's head over to Visual Studio and see how Swagger is enabled in some of our ASP.NET Core Web API templates. Swagger support in ASP.NET Core can be enabled by installing a NuGet package called Swashbuckle. If you're using the Web API templates in .NET 5, then this package will be available to you by default whenever you create a new project. Let's take a look at our startup.cs file and see how some of these things get set up. On line 26, I'm going to look at my configure services method. And inside here, you should see a call to add Swagger Gen. And inside of that, we're specifying the name of our API as well as the version. As we move down a little bit to the configure method, in the first few lines, we can see that we're enabling Swagger support, but only if our application is running in development mode. So that means that if you publish this app to production, then we shouldn't see some of these additional Swagger features. On line 41, we make a call to use Swagger. And this enables the generation of that OpenAPI document that we could use to get some really detailed information about our API endpoints. Then on line 42, there's a call to use Swagger Gen. And we point that to that API endpoint. On line 42, we make a call to use Swagger UI. And that enables that web page UI experience that we've been using so far to test out our APIs. All we have to do is point it to that OpenAPI document that we generated in that previous line. Let's go ahead and run this. Now that our page is up, you should have a good idea about where some of this information comes from. On the top left, we can see the name of our API as well as the version. And then on the right side, on the select definition, we can see the different documents that are available for us to try out. And so far, there's only one. In the middle of this document, we can see the different operations that are available on our API. And like you've seen before, we can inspect this and see the different parameters our API expects. We can try it out and run it live and see what it actually feels like. And also, we can see the different responses that are returned from our API. This is a really good experience, not just for building web APIs locally by yourself, but also sharing with your team so they can learn about some of the capabilities of your API endpoints. In a future video, we'll dive a little bit further into OpenAPI, and we'll learn about some of the other features that we could use to really customize this UI. Web APIs can return responses to the calling client in a variety of different ways. And those responses might represent successful operations, failed operations, or even operations we might want to retry. Also, we might want to associate some data with those responses. And so that could represent a collection of things, one thing, or maybe we just want to send over an empty body. In this video, we're going to look at some of the options for returning data from our web APIs inside of ASP.NET Core. You might recall from earlier in the series that our get operation looks something like this, where we were only returning a list of strings. And while this works fine, this operation doesn't give us the flexibility that we need to apply some of those web API conventions. Now, we still want to be able to return data from our API, but we also want to be able to control the responses that get sent back to the client. And we're going to see how we can do this using a facility known as ActionResult. Now, the first thing that we need to do to apply ActionResult is, well, I'm going to change the name of my return type, and I'm going to return a type of ActionResult. Now, the next thing I want to do is, well, I want to return an HTTP OK. That means it was a successful response, and I also want to provide the data. So what I can actually do is I can call the OK method, and then I can pass to that method the data that I want to have returned to the client. Now, you might be wondering, well, where exactly did this OK method come from? And it turns out there's a lot of helper methods that are available inside of that controller base class that will allow us to return action results. Let's try and return another one. Let's say, for instance, our recipes type didn't have anything in it. So let's say recipes.any was empty. Now, one of the things we might want to do is return a not found. And returning not found signals to our client that, well, we weren't able to find anything that you were looking for. And notice how we can do that by just calling the not found method. So not only can we return our data using a successful OK response, but we can also signal other types of responses as well. If you continue digging around inside of that controller base class, you'll notice that there's tons of other helper methods that are there to allow us to return common action results. Action results are really good for returning customized responses to our API clients, but they're also really helpful when it comes to generating the metadata that gets used in our Swagger UI. Now, stay tuned because in the next video, we're going to learn how to pull information out of the HTTP request using a concept known as binding. ASP.NET Core defines a lot of interesting types and properties that we could use to inspect the incoming request. We can even define the types of information we want to pull out of the request and have provided to our action methods as parameters. And this process is usually referred to as binding. Now, when it comes to binding, there's a lot of different parts from that request that we can get information from. So for instance, we might want to get information from the body or from an HTTP header or even the query string. And we usually refer to these as binding sources. And the way that we specify a binding source inside of our code is, well, we can use binding attributes. So we can use a from attribute and say, I want to get information from the header or from the body, or I want to get it from the query string. Now, let's take a look at a practical example and see how we can use these binding parameters inside of Visual Studio. Let's take another look at our get operation inside of our recipes controller. Now, a common ask whenever requesting resources is to be able to limit the number of resources that get returned from our API. And one way we could do this is by specifying a count parameter. Now, where exactly is this information going to come from? Well, like we mentioned before, we can use those binding attributes. And so here I'm specifying from query. So that means that ASP.NET Core is going to pull that from the query string. The next thing that I want to do is use that parameter inside of my action method. So here you can see I'm using the take method from link to return the right number of recipes. Let's go ahead and run this and see what happens. Now that my Swagger UI is up, let's inspect that get operation. Notice that I have that count parameter available for me to use. And I could give it a value and let's execute it. 1, so that's the right number, and then 2. There you go. So we know that the right value is being pulled out of the query string and supplied to our action method. Now, this is not the end of binding, and there's way more sources that we could use to supply information to our web API. But we're going to take a look at some of those a little further on in the series. We've mentioned a few times in this series that web APIs allow us to work with resources, but thus far, we haven't formally defined or modeled out what the resources would look like for our recipes API. We have to ask ourselves, well, what does a recipe look like? What types of properties would it have? And how would we pass that along in an HTTP message? Well, that's what we're going to talk about in this video. And along the way, I want to introduce you to a language feature for C#9 that will allow us to do that, and we call that records. Now, if you've ever written any C# before, you should be familiar with classes. And one of the use cases for classes is to allow us to model real-world things in our code. So classes can represent things like people or animals or even games. Now, classes can have properties and those properties can have values. When we talk about C#9 and records, well, records are almost exactly like classes, except that they added some additional benefits to them. We get support for things like immutability and equality. And we can also write a little bit less code whenever we're creating our records. If you take a look at the screen, you can see that I've started to define what a recipe record would look like. So I'll have things like the title, or the descriptions, or the ingredients. I even have a date time that represents when this actual record was created. Now, this isn't all there is to records, and I definitely recommend you head over to the docs to learn more about them. But for now, let's head over to Visual Studio and see how we can start working with records inside of our API. Just like you saw in that previous slide, I've gone ahead and created a recipes record and have added that to the models folder inside of our project. Now let's take a look at the recipes controller and see how we could use this new record. First, let's inspect the get operation. And you'll notice here that I'm no longer just returning an array of strings, but instead I'm returning an array of recipes. Also notice that I'm only filling out the title property, and I'm simply doing that because I wanted to keep the code samples small. But as you're building your own APIs, make sure you fill out as many properties as is necessary. Other than that, my action method is pretty much the same. I'm still receiving that query string parameter, and I'm still using that OK method to return an HTTP OK status. Now let's head down and check out the post operation. Inside of this operation, this is where we're going to create new recipes. So we're going to inspect the user or the client to send us some information that we could use. And well, that's probably going to come from the HTTP body. So notice that I'm using that from body binding attribute to associate that parameter to our action method. Once that's complete, we can either return a bad request if the operation failed, or we could return a HTTP 201 created, which means that everything was successful. Let's go ahead and try this out. With the Swagger UI up, let's take a look at the get operation first. I'll hit try out, I'll put a number here, I'll execute it, and then as you can see here, the data is returned to us in a JSON format, which is usually the default for our web APIs. But also notice that we're seeing all of those properties that are associated with our recipe record. Let's head over and check out the post operation. Now with the post operation, we're going to have to supply some information to our API. The good thing with this Swagger UI is that it fills out some of those properties for us. So all we have to do is change the values. I'm going to leave them as there is for now. Let's go ahead and execute this. And you can see at the bottom, I got a 201 status code. So now we've successfully created a recipe resource for our web API. But I want to move forward from these hard-coded values that we're returning from our responses. So in the next video, we're going to see how we can connect the data source to store and retrieve our information. We have a lot of options to choose from when it comes to storing our data. We can keep data in memory or export it to a file on disk. We can keep it in a local database or even choose to use a hosted option in the cloud. In this video, I want to show you how we can connect our web API to a database. And in this case, we're going to use MongoDB. If you're unfamiliar with MongoDB, it's a really popular open source database that actually stores its information as JSON documents. It has support across a wide variety of programming languages and even supports a C# client. Now, one of the things I really love about Mongo is that I have the ability to download their database server locally and use it while I'm doing development. And when I'm ready, I could switch over to a hosted option using something like Azure Cosmos DB. Now, if you want to know a little bit more about Mongo, I definitely recommend you check out some of our documentation. But for now, let's head over to Visual Studio and see how we can connect Mongo to our web API. Before we head over to Visual Studio, I want to show you the instance of MongoDB that I have running on my machine. Here I created a database called Cookbook, and inside of Cookbook, I have a collection called recipes. Now, if you're coming from the SQL world, a collection is very similar to a table. And inside of my collection, I have a lot of information that I pre-populated with different recipes that I really like. Now let's head over to Visual Studio. The first thing I want to do is add some of those connection string settings. And the way that we'll do that is using our app settings file. Notice that I'm including the connection string, the name of the database we want to connect to, and also the name of the collection. Next, we need to add that NuGet package that we talked about earlier. So I'm going to right click and go to Manage NuGet Packages. And now we're going to search for the Mongo driver. This is the official MongoDB package that we want to install. Notice that I have this little green checkbox there. That just means that it's already installed in my application. Next, let's wire up Mongo to our app. I created this little helper method here called add MongoDB. And what it does is look into our app settings file and pull out that configuration information and pass it to that Mongo client that we'd have gotten from that NuGet package. Inside of our startup.cs file, if we head down to configure services, you'll see on line 29 that I'm making that call to that method, add MongoDB. On line 30, you might notice I'm adding something else, the Mongo recipe data store. This is just a class that I created to make it a little bit easier to work with MongoDB and our recipes API. There's one other change that I think you might be interested in as well. If we take a look at our recipes record, you might see that I've added some additional information to it. I've added some more properties, and I've also turned ingredients from a string to another record. So now we can store more information about ingredients such as name, amount, and the units. The last thing that we want to do here is connect all of this to our recipes controller. Now, if you recall that Mongo recipe data store that we wired up in our startup.cs file, we can actually ask for an instance of that, and ASP.NET Core will provide it for us. And the way that we can do that is by creating a constructor for our recipes controller. And the parameter that our constructor accepts needs to be the interface that our Mongo recipe data store implements. So as you can see now, once we get that, we can start using it inside of our action methods. So if we take a look at our get operation, notice that we're no longer relying on those hard-coded values. Instead, I can use our data store to query for a collection of recipes. Notice that I'm still able to use the query string parameter to specify the number of recipes I want to have returned. Let's run this and see how it works. Here inside of my Swagger UI, I want to check out our get operation. I'll hit try out, and I'll enter the number of recipes I want to return. So I'm going to put 3 and hit execute. As I scroll down, you can see that we got that 200 status code, but also notice all of this information that we're getting returned. So not only am I getting the title, but I'm also getting the description and also detailed information about the ingredients such as the name, the amount, and the units of measurement. And now you've seen how we can move away from those hard-coded values and instead get our information from a database. In the next video, we're going to learn how we can validate data that comes over in our API requests. If you write software that accepts user input, rule number 1, never trust that user input. That could be a very dangerous and expensive problem for you to solve. Instead, we should always validate that input before we pass it along to the other parts of our code. That's why in this video, we're going to learn how to apply validation to our ASP.NET Core Web APIs. Now, we've already spoken about what the structure of our recipes resource looks like, but we actually haven't spoken about what makes a valid recipe. What properties are required? What properties need to match? Are there date requirements or expiration requirements? We need to be able to apply some of these validation rules to our code. One way that we could do that is by making use of some of the built-in validation attributes inside of .NET. So as you can see, I could use the required attribute or the max or min length attribute. I could use the email attribute, or I can actually even specify my own custom validation attribute if I wanted to. And after we've validated our resource, we need to be able to report back those errors to the client. And as it turns out, there's a spec for that. It's called problem details, and it's defined in this RFC 7807. Now, this defines a very common uniform way that we could report errors back to the calling client. And luckily for us, it's already built in and implemented inside of ASP.NET Core, so we don't have any work that we really need to do. So why don't we head over to Visual Studio and see how we could use some of these things. To get access to those built-in validation attributes, we have to add a using statement and include the system.componentModel.dataAnnotations namespace. And you can see that's what I'm doing on line 3. Now we can apply those validation attributes to the properties of our recipes record. On line 13, you can see that I'm making title required. On line 19, I'm also making ingredients required. Now, based on your API and your business rules, you might have other validation logic that you want to apply to your resource. Let's head over to the Swagger UI. And I want to look at the post operation. If you recall what this does, it accepts input from the user that it's going to use to make a new recipe. Notice how when I hit tryout, it pre-populates some of this information from us, but for the sake of this demo, I'm just going to remove these. Now when I hit execute, I get a 400 level status code, which means it was a bad request. And if we inspect the request body, I can see some details about those validation errors. Notice it says the title field is required, and ingredients field is also required. The format this is returned to us is based on that problem detail specification. As I mentioned before, these validation attributes are one of many options for applying validation logic to your code. I can even make use of something like the model state property that's inside of the controller class. I can implement iValidatable object, or I can even make use of some of the open source frameworks that apply validation. Now stay tuned, because in the next video, we're going to learn how we can update resources using JsonPatch. By convention, there are two HTTP methods that are used whenever we're updating resources, and those are called put and patch. With put, updates are issued by replacing entire resources, but with patch, we can update individual properties inside of a given resource. That means that for put requests, we usually have to contain that entire resource inside of the message body, but for patch, we just have to define the individual properties and the associated update operation. In this video, I want to show you how we can apply some of those incremental updates using something called JsonPatch. There you go, you probably guessed it. There's a spec for that. JsonPatch is a spec that defines how we can issue updates to resources inside of our web APIs. And it's defined in spec RFC 6902. So if you want to look it up, you can go ahead and search for that. Now, JsonPatch defines operations such as add, remove, replace, or even move. And if we want to implement this inside of ASP.NET Core, we just have to install a few NuGet packages. So let's go ahead and take a look. Support for JsonPatch isn't enabled by default inside of our web API templates, so there's a few NuGet packages that we need to install. First, make sure you install the Microsoft ASP.NET Core JsonPatch package. Next, install the Microsoft ASP.NET Core.mvc.newtonsoft.json package as well. These two are needed to enable that JsonPatch support inside of our web API. Lastly, make sure you install the swashbuckle.asp.NET Core.newtonsoft package. We need that to make sure that JsonPatch support works inside of our Swagger UI. Next, let's head over to the startup.cs file to enable these features. On line 32, notice I'm adding a call to add Newtonsoft JSON. Also on line 37, we're enabling Newtonsoft support for our Swagger UI by another method call. Last thing we need to do is actually update our controller. Now, you might notice that I have a few extra methods inside of here, but I want us to pay attention to the update recipe action method. On line 51, you can notice that I'm including a routing parameter of ID. This is going to represent the ID of the recipe that I want to update. In a parameter list, you can also see that I'm accepting a type of JsonPatch document. This type became available to us after we installed some of those NuGet packages. Now, inside of my action method, I just need to retrieve that resource, and then on line 59, I can call apply to. And that's going to apply all those JsonPatch updates to my recipe. Next, we just have to persist that to the database and then hopefully return a successful response. Why don't we head over to the Swagger UI and try this out? First thing I want to do inside of the Swagger UI is let's check out this get method. Now, this particular get method is going to return a single recipe. I'm going to paste in the ID of a recipe that I know I want to get. As we scroll down, notice this one says the best meatballs in the title. What do we use JsonPatch to update that title? So let's go to the patch. I'm going to hit try out. And as you can imagine, I have to give it the ID of the recipe I want to update. But now inside of the body, I have to specify the updates I want to make. So I want to update the title. I want to replace it. And then instead of from, I'm going to make this value. And the value I want to change this to is 30-minute meatballs. There we go. Now I'm going to execute that. And as we scroll down, I got a 200 level status code. So I hope that means that everything's working fine. Let's come back to our get operation and let's issue this request against that particular recipe. And once I run it, there you go. You can see that the title has been updated. So therefore that means that our JsonPatch request has worked. And now you know how to enable incremental updates to your web API resources using JsonPatch. As an exercise for yourself, why don't you try doing another update instead with an HTTP put? Bad things happen sometimes, but what matters is how we react and recover to those issues whenever they show up. In this video, I want to show you how you can handle unexpected exceptions inside of your ASP.NET Core Web APIs. Depending on the environment that you're hosting in, you might want to expose a different level of error detail by exceptions that get thrown in your application. On line 37, you can see that we have a call to use developer exception page. And this is included by default in most of the templates. And what this does is enable a reporting page that gives us a lot of detailed information about the request and the exception that was thrown. Now this is really useful, but it probably exposes a little bit too much detail than what we'd want to expose to our client. That's why on line 42, I'm using that call to the exception handler. So as long as we're not in development mode, we're going to use the exception handler instead of using that developer exception page. Now notice my exception handler is pointing to a /error endpoint. That endpoint is going to get handled by this error controller that I created. Inside of the action method, notice that I'm reaching into the HTTP context and I'm pulling out information about the exception was thrown, such as the stack trace and the message. Now it's at this point that you probably want to log this information to whatever error reporting system that you use. And then lastly, I'm going to call that problem method, and it's going to return a response in that problem details format that we spoke about earlier. The last thing that we need to do is actually throw an exception inside of our API. So I'm going to open up the get recipes action method. And you can see here, I've added a check for count. If it's less than or equal to 0, I'm going to throw an argument exception. Let's go ahead and run this and see what happens. So I'm going to go to the recipes endpoint. I'm going to try out my get operation. I'm going to put 0 here, and now I'm going to execute it. And notice in the response body, I get a lot of detailed information. Let's actually copy this URL and paste it inside of a browser tab. This is the developer exception page that I spoke to you about. Notice it gives us the stack trace, information about the query string, HTTP headers, and even routing information. And like I mentioned before, this is great, but definitely a little bit too much to be exposing to our clients. So let's stop this. Let's change our application to run in production mode. And to do that, we just have to make one quick change. I'm going to go to properties, and then inside of the project properties, I'm going to go to the debug section. And inside here, I'll change this from development to production. I'll save that. And now let's run this one more time. Notice that the Swagger UI is no longer loading for us. And that's exactly what we've expected, because if you recall, the Swagger UI should only load if we're in development mode. It does not load when we're in production. So far so good. Now in the address bar, I'm going to paste that API endpoint. And notice now I'm no longer getting that developer exception page. Let's actually take a look at the developer tools inside of the browser. Now I'm going to reload this page, and notice that I'm getting a 500 level status code. If I click on the details inside of the body of that response, notice how the error is formatted in that problem details format. So it gives me the status, the title, the trace ID, and some other information, but it does not give me as much detail as the developer exception page. Always remember, as you're designing your web APIs, we should never expose too much detailed error exception to the client. That could either be very confusing for them or expose too much information about our backend, which could be really dangerous. Providing documentation for our software is important not only for our clients, but also for our future selves. And that's no different for our web APIs. In this video, I want to dive a little bit deeper into the OpenAPI spec and show you how we can customize that Swagger UI experience to provide more detailed information about our project. Before we start customizing our Swagger UI, let's take another look at it to see what we get out of the box. At the top, you can see I have the name of my project, but right underneath it, I also have a link here that links to that OpenAPI doc that tells me details about my operations. If I head back to the center, I can see all of the available API endpoints for my project. So here are my error endpoints and then the ones associated with my recipes controller. When I took a look at these, I don't see a lot of information about what these exactly do. If I click on them, I can see the parameters and I can also see the responses at the bottom. When we look at the responses, notice it only shows me the successful responses. I have no idea what happens whenever exceptions or errors are thrown inside of my app. Let's take a look at the post operation. We can see an example of what the shape of the request body should look like whenever it hits our API. But again, as I scroll down and I look at responses, I don't see the correct responses. This doesn't return a 200 level status code, it returns a 201. And then I also don't see any error status codes being shown. Let's head over to Visual Studio and start customizing some of these things. Inside of my startup.cs file, I'm going to head down to the configure services method. And what I want to do is add some general information about my API. So I'm going to select this code block and I'm going to paste in some of my own information. Here you can see I've updated the title and I've also added a description, contact information, and also information about the license. In this case, I'm using an MIT license. I just need to make sure that I include all the using statements that I need for this. Now when I save this, I should see the changes inside of the Swagger UI since I'm using .NET Watch. And here you go. You can see that it's added some of that general information here. You can use this to add whatever general descriptions you need for your API. Let's see how we can add some more details to these operations. Back in Visual Studio, let's head over to our recipes controller. And for our get operation, I want to add a description using some comments. Returns a recipe for a given ID. All right, we'll save that. And when I tab over to Visual Studio and I refresh this page, it's not showing anything. I must be missing some more information. Let's take a look at the project properties. I'll go to project and I'll hit on properties. Now to make sure that those comments actually generate documentation, I need to hit this checkbox to enable the generation of an XML documentation file. What I'll also do is I'll remove the absolute path and just make this a relative path. Now, if any of you have ever turned this on before, you know that that could generate a lot of warnings sometimes. So I'm going to let Visual Studio know that it should suppress those documentation warnings. Let's save that and let's head back to that startup.cs file. We need to let Swagger know that it could use that documentation file for our API descriptions. Let's include these using statements for these missing types. And here in this code I've just pasted, I'm just grabbing that generated document and passing it along to Swagger. All right, let's save this and see what happens now when we head back over to the Swagger UI. So if I refresh this page, notice how my description is now getting included in my operation. But we still have the wrong status code, so let's see if we can fix that. So back in Visual Studio, I'm going to go to my recipes controller. And there are two attributes that I want to add to my controller. That's produces and consumes. And these attributes let the Swagger tools know that we're producing and consuming JSON inside of our API. Now going down to our get operation, we can use some more attributes that will specify the status codes that this operation returns. So you can see I'm using the produces response type, and I'm saying it returns a 200 OK and also a 404 not found. Let's save this and head back over to the Swagger UI. When I refresh this page, let's click this operation. And there you have it. Now I have my 200 success and also my 404. Notice the media type that's here only says application.json. And that's because of those attributes that we added to our controller. And now you've seen how you can start customizing that Swagger UI by adding some attributes to the controller. Why don't you start going through some of the other operations in the API and add some attributes of your own? In the next video, we're going to see how we can take some of this documentation that we're generating with Swagger and use it to generate Web API clients. Throughout most of this series, we've been using the Swagger UI to debug and test our web APIs. But don't get mad at me if I tell you that there's another option as well. We can use the HttpRepl to explore our web APIs, and we can do it all via the command line. Why don't we take a look and see how it works? The way that we work with the HttpRepl is by invoking it on the command line. So I'll type in HttpRepl, but notice that I don't have it installed. So we need to issue this command, .NET tool installed, and the name of the package, which is Microsoft.net-httprepl. Now that it's installed, I should be able to type httprepl-h, and I should be able to see all of the available options that there are. So notice that I could connect to a particular API, I can issue various HTTP commands, and I even have the option to navigate through an API. So let's clear the screen and see how we can connect it to our web API. Our base URL is localhost 5001. So let's do HttpRepl, and I'll give it the base address. And now we should be connected to our API. If I wanted to see what endpoints are available, I could use the ls command. And since our recipes endpoints are prefixed with the /API, I need to navigate down that path. Let's do /API. Now let's navigate down one more level and go into that recipes path. Now inside here, I can just type get, and that will issue a get request against the /API/recipes endpoint. Whoa, and there you see it's returned to us a collection of recipes. What if we wanted to just get one recipe? Let's grab the ID from one of these recipes. I'll type in ls. And notice that I have the option to invoke an endpoint with that ID token. So if I type get, and pass in that ID, when I hit enter, it should just return that single recipe. The HttpRepl allows me to navigate through my API, just like I'm navigating through folders on my desktop. And this is all powered by that OpenAPI specification that we've been talking about throughout the series. Now, let's say you actually wanted to use a UI. I can type UI, enter, and this will actually open a browser tab with the Swagger UI. So you have the option to go between both if you wanted to. Using the REPL allows you to do more than just issue GET requests. You can use put, post, patch, delete, and tons of the other ones. I can set the HTTP headers, and I can even set the body that gets sent over in the request. If you're a person that prefers working in the command line, I think this is a great option for you to check out. Adding support for OpenAPI allows us to do more than just generate documentation. We can even generate Web API clients as well. Let me show you how. Before we actually start generating Web API clients, there's a couple changes we need to make first. Notice for all our recipe operations, none of them actually have any names. So if we generate a Web API client, what is it going to call these things? Let's see how we can add these inside of Visual Studio. Inside of my startup.cs file, I want to head down to that configure services method. And inside of that call to add Swagger Gen, notice on line 57, I've added a call to an operation called custom operation IDs. And what this is going to do is assign operation names based on the name of the actual action method. Now I need to make one more change inside of my configure method. Inside of the call to use Swagger UI, I need to call a function named display operation ID. So with this being said, I should now have operation IDs being shown on the UI and also generated in the OpenAPI document. If I head back over to the browser, notice here on the right side, I have all these operation IDs that are defined for me. Now let's go back to Visual Studio. I went ahead and created an extra project, and this is just an empty console application, and there's no code in it right now. I want to use that generated Swagger document to generate an API that I could use inside of this project. I'm going to use that generated OpenAPI doc to generate a Web API client that I could use inside of this project. First thing I'll do, I'll go to Project, and then I'll add Connected Service. Now here under Service References, I'll click Add. I'll select OpenAPI. I hit URL, but now I have to paste in the address of that Swagger doc. But you remember where we can get that. That's right here underneath the name of our project. So I'll copy this and I'll paste it inside of Visual Studio. Next, we need to give it a namespace. I'm just going to call this Recipes API Client. Now I'll hit Finish, and it's going to install some NuGet packages for me. And now I should be able to access that generating client inside of my project. So let's add a using statement and include that recipe client namespace. And now I should be able to access a client. And I believe it's called Swagger Client. Notice that the Swagger Client needs an instance of HTTP client as well as a base URL. Well, let's get the base URL from our Swagger UI. So I'm going to copy this part. I'll paste it in, and that'll be a base URI. Now I need to create an instance of HTTP client. So I'll just quickly new up a new instance of HTTP client, and I'll pass that into this constructor. Now using that client, I should have access to all those API operations. So if you take a look here, notice I have create recipe, delete recipe, read recipe, update recipe, and all of these operation names are based on the operation IDs that were generated inside of that OpenAPI spec. Let's do a get recipes call. And you can see it accepts that count parameter. I'm going to say I want about 10 of them. Now I'm going to specify the results. And now why don't we go ahead and loop over these results? So I'll do a for each item and results. And now I'm just going to console write line out all the recipes. I'll do item dot, and I'll just print out the title. Now let's run this and see what happens. I'm going to select the console project. I'm going to hit debug and start without debugging. And here inside of this console window, you can see the titles of 10 random recipes returned from my API client. Hopefully you see now how a well-formed OpenAPI document can not only help us debug and document our web APIs, but can also help us generate API clients. Now we can take all of this code and package it up in a NuGet package so different folks all around the world can start using our APIs so much easier inside of .NET. Running tests for your software is important, but it's even more critical before you go to production. In this video, I want to show you how you can write unit tests for your action methods that we've created for our web API. The method that I want to start creating tests for is going to be this get recipes action method. First thing that we'll do is go ahead and add a test project to our solution. So I'll select add, new project. And with the test filter selected, I want to select the XUnit test project. I'll select next. And now I'll name my project Contoso recipes.test. Now, before we move forward, I need to check the properties of this project. Since our API project is using .NET 5, I need to make sure that the target framework for our recipes test project is also .NET 5 as well. All right, let's close this. Let's rename this class to recipes controller test. Next, I'll rename this test method. This is just one of the naming conventions I like to use whenever I name my test methods. You might have your own that you like to use instead. Now, inside of the test method, I like to use this pattern called arrange act assert. Inside of my arrange section, the first thing I'll need to do is add an instance of my controller. Now, my test project doesn't actually know about my controller yet, but if I hit this little light bulb, notice that I can add a reference to my project. Now, Visual Studio is highlighting an error here, and that's because whenever I create a recipes controller, I need to give it an instance of the iRecipe data store. And if you recall, our data store actually references MongoDB. But for the sake of unit testing, I don't want to have a dependency on a database. I just want to be able to test the functionality of the controller. So I'm going to need to create a fake instance of that interface so I can write this test. And one of the ways I'll do that is by adding one of my favorite NuGet packages for testing. And that project is called Fake It Easy. I'll go ahead and install that package really quickly. And then it also looks like I have some updates here. I'll go ahead and update these packages as well. Heading back over to our test. let's go ahead and create that fake instance of the data store. And with Fake It Easy, it's as simple as saying a data store is equal to a.fake, and I need an instance of I recipe data store. Now let's go ahead and include the using statement for Fake It Easy. And now I can pass that to my controller. Since this is a fake data store, we need to tell it what to return whenever a method is called. If we take a look inside of our controller, notice it's calling this method getRandomRecipes. So let's see if we can fake that out. I'm going to use the call_to method, and here I'll pass it a lambda. And so I'll say a call to my data store of getRandomRecipes. But what is it going to return? Well, we know that we're going to need a count, so let's go ahead and add a count parameter, and I'm going to set that to 5. And I'm going to use this count parameter inside of that getRandomRecipes method. Now this is an async method, so it needs to return a task of something. So I'm going to use the task.fromResult. But what exactly is that result going to be? We haven't given it any data yet. So another thing that we could do is create some fake data. I'm going to use the A collection of dummy operation from Fake It Easy. And what this will do is create a collection of fake recipes. And now I want that to be of type IEnumerable, so I'm going to use the asEnumerable method. Now we can pass that fake collection of recipes to this operation. That should be it for our arraign section. Now we should be able to go ahead and invoke the action we want to act on. So now I'll say controller.getRecipes, because that's the action method that we wanted to test. And then we'll pass it the count. And that would simulate the query string that we'd get from the request. And now we know our controllers return action results. Now, since this is an async method, we're going to need to make our test async as well. Now, last thing that we need to do is actually assert the values are correct. Now, what we need to do inside of assert is grab the action result, and then we need to convert it to the correct type. If you recall from our controller, we're actually returning OK, which returns a type of OK object result. So that's why I'm casting this result to a type of OK object result. And from that result, I'm going to get the recipes back. Let's go ahead and include the using for IEnumerable. And now I can actually assert. So I'm going to assert equals. And the expected value should be the count. The number of returned recipes should be recipes.count. All right, there we go. Let's check out the test explorer. And in a second or two, you should see your test pop up here. Let's go ahead and run these with the run button. And there you go. Now we have a passing test. I always feel so much better after writing unit tests for my code, because that means that I can deploy my application with that much more confidence. Why don't you give it a try and add some unit tests for the action methods inside of your web APIs?